Can anyone hear me? Okay. Thank you, Hetty. Yeah, this is the talk I gave in PG Day Chicago. I got some really good feedback. So this is a little bit of revised version of it. So I'm going to talk about how we set up integration tests with PostgreSQL from a perspective of an application developer. So I'm Doğaç, and in this talk, I'm going to talk about unit testing, integration testing, transactions, save points, using a template database, truncating versus delete, using the PLPG SQL functions, triggers, session replication role, unlock tables. I'm not going to go into like in depth for each one of them, but we're going to see how we can use them. So I'm currently a master's student at Northwestern University. I just started in this fall quarter. Before that, I worked as an application developer at Carbon Health, a healthcare tech company, where I have actually developed this presentation in April 2025. I'm also an open source contributor. I like contributing to some projects such as Armeria, which is a web server, Kotlin-X, Protobuf, serialization libraries. I was in the platform team, so I worked with other developers closely, and I learned a lot by observing what other developers are doing and what they need as a team. It was important for us to understand their needs and build solutions for them. And yeah, my hobbies are like running, photography, piano, etc. And I live in Evanston. Evanston is for whom live in Chicago, you probably know it's the north border of Chicago. It's where Northwestern campus is. And those are the 4 pictures, 4 seasons. It's a beautiful city. Yeah, the background of our company, it's a tech-enabled clinic company, and we had our providers, patients who use mobile and web-based applications. So this application was being used to manage their care. They were able to see their prescriptions, lab results, and they were able to communicate with the providers, schedule their appointments, etc. And our tech stack was a monolithic server supported by 30 plus microservices, but monolith was still one of the biggest components. We host our services cloud, and our primary choice of DB is PostgreSQL. We had some other NoSQL options, but they were just supporting. We had over 500 tables serving more than 10 terabytes of data. In healthcare, you might need a lot of tables for a lot of different things, and they might come from external vendors, or you might just populate them by yourself. We had about 6 distinct development teams. So as a platform engineer, we had to account for their needs. So this is what our application looked like. It was primarily for providers, the iPad app. And on the bottom, you can see the scheduling part, which is both web and mobile based. So our team's responsibilities, we made architectural decisions. For example, the microservice decomposition was initiated by our team. We had core libraries. So we had some wrappers around the ORMs we are using in our company, and also we wanted to control like the web controllers, web servers, and such configuration in a unified way. We had CI/CD pipelines managed by us. We worked on authorization auditing for the security perspective and compliance requirements. We had infrastructure management, so we had Terraform modules. We managed them, and we helped with other teams, worked closely with DevOps. We also helped the developers roll out their database migrations, especially when they are big and they are prone to locking, causing some trouble. Also, we've done cost and performance monitoring to ensure our cost was low and performance wasn't struggling. So the type of tests, in this talk, I'm going to concentrate on integration tests, which was the most important kind of test in our company. So if we were to compare unit testing to integration testing, so first is isolation. In unit test, you are able to isolate your code much better than integration testing because you are taking a much smaller chunk of code than you are testing it under very strict conditions. In terms of speed, the same reason makes unit testing much faster. For integration testing, you need the whole environment to be working on. But on the contrary, for failure detection and coverage, we realized in our company, integration testing was performing much better, and it was helping us to deliver applications with less production failures. In order to improve our integration testing environment, we have to focus on those two things. Isolation, mostly driven by the DB, because it's the stateful part of our stateless application, and speed, which we will get into the developer efficiency part. So to go over, I'll give a sample unit test. This is what you see in a textbook example. So it's just testing the method called utils.add. In case this is very simple, if you were to translate into the healthcare context, you just use this parse dose, for example, to parse some kind of medications dose, and we are making sure its unit is matching and its value is matching. So if you want to do it for the controller, which is one of the endpoints of our application, we are using mocks because we don't have access to a real DB. So we have to mock the behavior here in prescription repository. This example is following the repository controller pattern. So we mock the data. We just say when prescription repository.getAll, then return this list. In fact, this is Scala, but I think it's really easy to understand because it's really close to natural language. And we're just asserting our controller.getPrescription method is returning what we've expected. For example, it might do some parsing of those inside. We don't know. We are just testing the behavior end to end, and which usually code the bugs that have been caused by code changes. On contrary, if you want to do integration tests, first major difference is we need to have some kind of environment. We have to integrate with the external environment. And in this case, I've just abstracted it as an environment setup, but in the context, we're going to have DB as our primary state. So if you were to test this, we can just insert an entity using the prescription repository, and we will get our controller. In this example, I've used dependency injection, which is pretty common and helps you to mock some certain stuff during tests. And I've later asserted. So why do I need to check the controller? Because we have queries like this written in ORMs. In this case, it's a functional relational mapping library. So it's complicated. It's not pure SQL. You can't directly just compile this and test it. So in order to test code blocks like this, we have to really run it on the DB to make sure our changes are not causing any unexpected failures. So integration tests, recap, most of the time we need real DB to catch the bugs. Test isolation is important, but the database is stateful. The isolation is important to catch bugs, and we are making sure we are not creating any race conditions or things that are not real bugs. And there is no guarantee if a test leaves the database state clean, because we can't make sure every test is gonna clean database after they run. Maybe they will fail. Maybe the developer will forget to clean something. And foreign keys and dependencies in data make initialization hard. Sometimes we use reusable scenarios to help developers build tests. For example, in our application, we might have an appointment fixture, and this appointment might be reused among tests to make sure developers are not dealing with the complexities of the data, but just focusing on the business logic. So yeah, as I said, unit tests, they don't catch bugs as often in our application stack. That was our experience. So first intuitive approach is wrapping our test with transaction. So we can wrap the whole test with a transaction block, then just roll back. That's the most simple way of doing it. And if I remember correctly, that's how Ruby on Gems is approaching tests. But it might cause conflicts because in our application code, we might depend on actual transactions. So in this example, we are creating a transaction, then we are inserting a value, but in this case, application expects this value to already exist, and it's throwing an error. So it wants to fetch that, but it doesn't work because we are currently in a transaction block. But in our application, in real life, this was two separate transactions because we wrapped it in a parent transaction. It didn't work. And we rolled back. So the test failed, but it should have worked properly. So two things: expected errors will abort the parent transaction, so app will not function, and application code can commit or roll back during this parent transaction block. So what can we do? We can use the save point in PostgreSQL function, which is used to replicate the nested transactions. If your ORM supports it, it might work. We had two primary ORMs. One of them is Scala Slick, which didn't support, and the issue is open since 2016, so I don't think it's going to support soon. And the other one was Kotlin Exposed, which supports, so we didn't have this. We could have used this there. So we just create the transaction with begin. Then we set a save point in this call. I just called it X1, and we're just going to push this save point to our stack. Then we're going to run our code. Then after it fails, we can just roll back to X1 instead of rolling back the entire transaction. Then we create another save point because we want to run another operation. This is simulating another nested transaction. We fetch our select. Then in this case, the test has ended and we just roll back. So save points are working when your stack is supporting it. So the second approach, a new DB for each test. This is the second intuitive approach. So if you are concerned about your state, just recreate it. What are some issues? So we have 400 plus tables. So that's going to take a lot of time. And we have 1,600 migration files. Because we have so much, we can benefit from two approaches. Like one of them is taking a schema dump and restoring it with PSQL CLI tools. And second one is using a template database. So also we can create multiple schemas or databases, and this will help us to run tests in parallel. And each test is going to be fully isolated. Like we are not expecting any kind of leak. So how can we do this? So when you call create database, you just pass an argument called isTemplate, and we can connect to this new template database. We can create a table here, like a people table, and we insert some values. Actually, template databases are not just databases of your definitions. They can also store values. And you can create another database like unit test 1, assuming it's a run-off unit test. It just creates the same database as the unit test template, and it just fills the data. And if we see, if you look, like it has the same people, and we can inspect our current tables with this command. Like you will see your database is going to have template 0 and template 1. We've created unit test 1 and unit test by ourselves, but those other two are the system defaults. And if you want to query it, you can create from PG database table. And it's going to show you two properties here. Like one of them is whether it's a template or not, and whether it allows connections or not. And the only one that doesn't allow is template 0. And I will explain why. So create database actually works by copying the existing database, and it copies the standard system database called template 1. If you don't specify, when you specify, in our case, we were copying the unit tests. And template 0 is a fresh version of the database, and it doesn't contain any modifications. You are not allowed to connect because it's the PostgreSQL's way of creating first template 1, and you shouldn't change it because it's the core database template. So Postgres copies the whole structure on the file level. That helps with performance. And one thing to note is it doesn't copy database level grant permissions. In our case, we didn't care, but it might affect your workflows. So what about data dependencies? So in this example, we have a practice, which is like a clinic, and the clinic might appear in multiple locations. It can have multiple patients, doctors, and appointment contains something called a case, and it can contain prescription. And this is really annoying to deal with as a developer. So you have to figure out all the foreign keys. You have to understand their relations. You have to insert them in an order. So as a platform team, we try to come up with something to make developers' lives easier, because if you don't, then they don't want to write tests. They will push code that is not well tested. So what did we do? In this example, we've created something called a smart fixture, which is actually a tree of dependencies predefined in another file, and helps you to set up the whole code in a certain order, so you don't have to worry about the practice, location, and other things. So if we dive deeper into this, like there is a sample appointment under the appointment fixture. We just give the entity's ID, patient ID, and other fields. We also define a set of dependencies here, like the patient fixtures, doctor fixtures. So when you try to insert, it knows what to insert first. And we have a short setup script here. It just does it just traverses the visited thing. It just traverses the fixtures dependencies. And if it's not set up yet, we're gonna set it up, and we're gonna insert our database entity. And this makes sure we are not breaking any foreign key constraints. So returning back, instead of adding via the repository, we just use the smart fixture. And now developers don't write 20 lines of code. They just write 1, and they can reuse it. So we also make sure there is database providers being refreshed in between each test, because if we don't, then that prescription is going to get stuck. And if it gets stuck, you might get unexpected results from select queries. You might see problems on inserts. So you want to add this trait. So in order to also make our developers' lives easier, we are just adding this trait as a separate trait interface. In other words, like this interface just create fresh before each, before all. It's just cleaning the database in between the rows, and it just destroys it afterwards. So in those create fresh and destroy commands, we are actually running our rake. And this is, as I've shown, you could have also used template databases. In our case, we were using this one. It worked fine. It was a little bit slow, which I will get into. So, and we extend our test. So it's just a 2 words change to make sure your database is clean. This is how I have an example integration test look like. So some cons. First of all, initialization took like 400 milliseconds. And we can sacrifice some stability by creating a single database per spec. It also means like file. So it contains multiple tests connected to a single DB, but you still have the same problems. It's just more isolated. So when you face it, it's easier to fix. And we had more than 9,000 tests. So if you just do this for every test, you're going to have an hour of overhead just creating the DB. So you don't want to do that. So the third approach is deleting all the tables. So our initial approach was this. After trying the database, creating from scratch, we decided to do this. And we had a handcrafted list of tables that was ordered in a specific way. So the foreign keys were all in the right way. At least we thought until we saw something causing issues. And we actually had some missing tables. We realized that after doing sanity checks after years. So it's theoretically faster than recreating the entire DB. But you have to make sure you are sending your old deletes in one connection because we have 400 tables. We were sending them in single connections. Like if you trust your ORM, it's just going to use a connection from the pool, then it's going to put it back. It takes a lot of overhead when you're doing it like a million times. Sequences and materialized views need special attention. In our case, we don't use them in our production code widely. So that might be something irrelevant in this context. Also, we tried truncate. So if you know what truncate is, it just deletes the entire table. It's an efficient way of doing it if your data is big. But in our integration tests, we only had a few data points because the whole point is being able to isolate and run the tests and make sure everything's fine. So let's compare those two. Truncate is a DDL operation, delete is a DML operation, and truncate takes an access exclusive log, so it logs the entire table from being accessed, read, or written. Delete is less restrictive. It can do row level logs. Truncate actually drops all the data instantly from the file system, so it's just being recycled by the operating system to be reused. But delete is just marking rows as deleted, so it's been managed by your Postgres engine to be reused. So you are not just giving back your space to the operating system until you run the vacuum operation. So truncate, you don't need it. Delete, you need it. Also, one minor detail, you can't run truncate in a transaction. It just auto commits. Delete doesn't. And the file size, table file shrinks as data is removed on truncate. So this operation of file system synchronization causes the overhead from deleting empty tables. Like even if it's empty, even if it's small, you have a lot of IO overhead. So in our case, that's why for small data, delete is faster. So the implementation, this was what it looked like. We are modifying our interface for the clean DB between tests. And here we are just having a bunch of SQL queries for deleting. And as I said, because this is managed by our ORM, this is just sending those requests in separate queries, separate connections. Maybe it reuses, but it still has enough overhead to be slow. So what can we do? We can use the PLPG-SQL functions. So what are they? They are the procedural language for the PostgreSQL. It allows us to write functions, procedures. They can perform complex computations. They can be used for triggers. So why use them? Because we don't want the extra round trips. Even though it's in the same machine, we are looking for performance and we don't need that. So second reason is intermediate results. We don't need them. We don't need the result, marshal the first query, second query, fifth query until the 400th query, then just get their results back. We don't need that. So instead of sending 400 separate statements, we just bundle them. And I think it's also helping with the query planning. In this case, we were using just deletes, so it might not help a lot, but for other cases, it might help with the query planning. So a sample function looks like this. So we just create a function called clean all tables. We just write the same statement 400 times with different table names, because why not? And in order to call this, we just call select, and it gives the result. And in this example, it's actually void, so it doesn't return anything, but this is how we call it. So we update our implementation now. So instead of cleaning all the tables, we make sure we set up our functions first. And in order to do that, we use the create or replace function, because if the function already exists, we don't want to throw an error. And here we're just doing a small string manipulation to make sure we are giving the lists in our application. In this example, we just use a list here, but you might also use your ORM's objects and other things, or some helper methods. And later we just call the, and you just call the clean all tables. And this wasn't enough. We still had a bunch of overhead. This was taking like 150 milliseconds, and we didn't like it. So we wanted to have a better solution. And we've been using this for the last 2 years. So let's revisit. Before each test, our tables should be fresh. And the cleaning DB should be as fast as possible. And we have over 9,000 test cases. So for local development and CI, it's ideal for the developer experience. And handcrafted table list is annoying. Entropy always wins. So you can't really maintain that. It didn't work out. And the funny thing is, once it broke down, it was actually really hard to debug. So it wasn't just costing the person's time, but it was also costing other people's time, because you don't know how a foreign key constraint might be related to a failure, because you just added like 500 tests ago and it suddenly changed due to the order of things. So the idea is, what if we record the tables that are used and wipe only those tables? We don't want to delete from all the tables. So the implementation, let's first start with creating a record, for creating a table to record what's been accessed. And this is a very simple one. We just record the table name. And in fact, it's going to include the schema as well. So we can create a trigger, which will be run every time an operation has been run on this table. And this was the initial implementation. We are using the TG argument thing to get the argument that's been passed. But I've learned that you don't have to use that, because you can use TG table schema and TG table name. So which is really handful. And also I realized if the operation is delete, then you have to return the old row. You shouldn't return the new one, which is actually that tuple. So we would like to set up triggers for all of our existing tables. And this will be executed before every insert. So we make sure if it's being inserted during tests, we know what to clean. And the actual implementation is, we create the setup access triggers function, which queries the information schema for tables. Then we find all the tables in the given schema, which we will pass in our application's unit test configuration. And we exclude 2 tables, test access, because it will create a recursion. We will always insert the test access, and it's going to just repeatedly insert itself. And schema migrations, I don't think it's super important, but we just didn't want to delete that. So we are going to execute this function to create the table for each table in our tables. And we just drop the trigger if it exists, because it might not be the right one. And we are creating the trigger again. And this is just running the procedure add table to the access list. And we are doing some string manipulation to name the trigger, and also tell it like which table schema and which table name to use. So you don't have to pass the argument here, as I said, because of the parameters we've used. And it just returns 0. We don't care what it returns. Maybe it might not be the right thing to return, just realized, but we didn't face any issues. So we also create the function for deleting from the access tables. We just create this cursor to iterate over all those test tables that have been accessed. And we just define this as select table name from test access. And we set our session to be replication role. I will get into the details, but this helps us to just overcome foreign key constraints because our whole goal is to make sure we are deleting everything. So foreign key order doesn't matter when you delete everything. So I suppose in our case, it worked out fine. And we iterate over each table, then we just delete from the statement.table name. And when exception happens, exception when others, like we just don't do anything because the table might be temporary. And if it's temporary, we don't want to throw an exception and fail the whole suite. Like we just want to skip. Then we execute this function to delete, to clean up the recorded values. We don't need them. We just set the replication role to be origin. I think it doesn't matter because it's inside the function and it's a separate connection, but just to make sure I put it there. So why session replication role? So there are three possible values. The default one should be origin and replica and local. I didn't find a use case for local, but I'll explain the details of origin and replica. So the intended use is to do logical replication when you are applying replicated changes. So because you are replicating changes, you can't rely on foreign key constraints too, and the triggers are disabled during the logical replication. Because triggers are disabled and foreign keys are implemented as triggers, they're not going to trigger. If you want more granular control, you can use alter table and enable trigger statements to just disable them per table. So after a failover, new writes will enforce foreign keys again. So existing bad rows will remain. That's also something I think will happen if logical replication takes over. So the implementation, we just update the clear access tables to be those two functions and the setup test triggers. We just add this test schema parameter. This is our schema where our data is living. So if you want to have multiple tests being run, you can create multiple schemas and just assign them in the setup test triggers. And the rest is the same. To install, like I created this small script. If you're a system admin, you can just call this if you trust this. And if you are using a Docker image, which I recommend because we are doing an integration test, we usually run our Postgres in Docker. So you can just use this and it's going to automatically install it in your Postgres. We encourage Docker. So our results, we've been using this for 2023 May. So we had no isolation or stability issues so far. Only issues were related to developers not using this new interface, new trait of clean DB. So it was pretty easy to fix and the failures were pretty easy to spot. And we've seen a reduction of around 30% time in our CI runtimes. When you think about it, it's crazy that we were spending 30% doing nothing. And our number of tests is growing faster than ever. When we implemented this, there was 6,700 and now it's more than 9,000. And this is a recent one. I just run the test by reverting back the changes after 2 years. And there was one failing test. And I suppose that's because of the order of things being cleaned. And there was a 15-minute addition. Right now, it's not as high as 30%, but back then it was like 45 minutes in total. So it was much more significant. So there are still some things to explore. One of them is like, how can we support global constant rows? Template databases support this out of the box. If you are using a template, as I have shown, it's okay. As I have shown, you can just keep the rows in the tables. And you might need to reset sequences or materialized views. So probably, we haven't done this because we don't need it, but you can leverage the information schema again, create similar functions to be executed in between each run. And the third thing is we can use unlocked tables to increase performance. So persistence is not needed for tests, and unlocked tables do not write to the write-ahead log, and it should create performance gains. We haven't tested it. I don't work here anymore, so I couldn't test, but it should be a nice idea to try because it's really easy to try. This is syntax for it is this create unlock table, alter table. You can use both to modify your table. And because we don't write to the file system, we don't wait for the disk, and CI/CD, you don't have the best disk. So it probably helps. So there are some additional sources that I benefited from. There are some blog posts, there are some libraries, and the PostgreSQL documentation was a great place for me to prepare this presentation. It's really easy to understand and it helps a lot. So thank you for listening. I've uploaded the slides and the code. My extension is in this GitHub repository. If you scan the QR, it goes directly to the GitHub. And I've also written a blog post in the past, so you can also read that. So thank you. Any questions?
Yeah, so thank you so much. You know what I find actually most impressive? I don't know what other people think. I find most impressive that people actually have the tests. And they have they actually test things because yeah, like many companies just don't do this. So I think that itself is super remarkable. And yes, any questions, please?
A question here.
Okay.
Yeah. Can you give examples about that entropy is better than handcraft structure?
Okay, let me find the slides where I mentioned it. Yeah. So what I mean is we have a fixed list of tables. We start adding new tables and there is no 100% guarantee. Over time, the system gets more complex. Over time, we just grow our table sizes and we realized every 6 months or so, it just blows up because somebody forgot to add, some order was wrong, but the wrong order was never noticed because the tables were always empty and etc. So that's what I tried to mean by entropy. Is that what does that clear up what I said?
No, not really.
Okay, can you come again? Can you ask the question again? If
basically you are saying entropy is better than handcrafted table.
No, I meant like entropy always takes over your solution. It always beats you. You can't beat systems entropy by using the solution. That's what I tried to mean.
Okay.
Entropy is not better. It just defeats you.
Fact of life.
Yeah.
Okay, I apologize. I'm trying to do something with lights. So tell me what will work and what won't, because it's like one month when it was happening. So if I will just turn the lights on, will it flash? Let me see. Okay. Now it will be like no question in October. All right. Yeah. Questions?
So did any of your tests do like large bulk loads and things like that? And did you have to run into ensure that your logs and all weren't filling up?
None of our integration tests were loading very huge chunks. There was one specific set of tests that were loading from a like 300 megabyte database, but it didn't have any inserts. So we were lucky that we didn't do any, testing on big data that has inserts.
I'm really curious. So you don't work at this company anymore, but if you wanted to, let's say, distribute this to another company and kind of implement this in their code base, let's assume it's also like Scala, right? What would that look like? And are you confident that this is something that you could kind of move to other systems?
I think it will work pretty well in a web application because the application itself is designed to be stateless. But I didn't really thought about in other perspectives like embedded systems, how like I don't think you will do embedded with Scala, but I think it will port well with web applications mostly. So I will try. It wouldn't hurt. It's like 4 lines to install, and
Oh.
I would give it a shot.
Okay, while other people are thinking, I want to ask my question. And like, as I said, I'm super impressed with like exhaustive test coverage. So I want to know how you made decisions on like what the test should be, how you made sure that you cover all the cases. Is it like from practical experience, you know, things failed, or you were like super good in projecting what might fail and what you need to test?
In our company has experienced rapid growth during COVID times, so it was crashing a lot. And actually, we've also released a small research paper on our monolith to microservice decomposition, and we've decided to add this testing constraint on the upper level. Like everyone is testing their code, not just by hand, but also making sure those DB queries are actually running, because we had a lot of locking issues and our controllers were not really like well structured as a repository controller pattern. We were sometimes running just the query directly in the controller layer. So we wanted to test everything. Like RPRs weren't being approved if we didn't do that for any piece of code. If it didn't even had tests in the past, if you change it, you must add it. That was the approach.
So regarding the data size, because you mentioned locking, and to like emulate locking, you need some sizable. So how is it? Because I like missed it. So how is your test size kind of match the actual like real data size in production?
Yeah, for locking, it's really hard. So the couple approaches, we've done those approaches in the future. Like we broke down some of the joint queries, and they were also being reviewed. But in those tests, as you said, like it's not possible to catch those database logs under huge pressure. But in our case, we were more concerned about the data integrity, because when your data is not correct, it might have also violated some of the assumptions in the front end, and it was causing the whole app to go blank, for example. And integrity was the first goal of the tests. Yeah.
All right. Any more?
I might have missed when you talked about this, but did you explore running tests in parallel at all? I know that's a whole different set of challenges.
Yeah, we tried. We are actually sharding our tests into multiple CI instances because we are getting a pretty good CPU utilization on a single CI machine. So we use a library called, we use some library for Scala's test shards. We run them in separate machines, not in a single machine with being sharded, because our utilizations was high during the runs. And as I said, like it should be possible to just modify this slightly and run it with multiple threads. But as I said, like CPU was the bottleneck, so we didn't try.
Okay, I guess I have two questions. First is, I thought it was really cool the way you were tracking like which tables had been updated and only dropping those. Was that like the biggest, I guess you kind of went over like a number of different things you did to improve performance. Was that like the biggest gain that you got, that insight? Or would you say there was something that like really took a chunk out of like?
I think the biggest improvement was when we created a single PostgreSQL function to send the whole deletes, because we had a lot of overhead from running it like 400 times. And we couldn't do that just by simply modifying our code to run in a transaction, because it just didn't work that way with our library. So that was one of the biggest speed ups. And using the test access table, that was like a polish on top. Like the actual idea was just directly implement the test access. That was a side effect we realized later on, like, oh, we were just sending multiple connections and it reduced to one. That also helped. So that was a learning that happened after we implemented it. So I would say that one.
Thanks. When you originally ran the tests a couple of years ago, do you happen to remember what storage was being used on the machine on which you were benchmarking?
We were using the GitHub CI runners by default. So I don't think their storage was like, I don't know, but I would just say they were not good. Maybe a disk storage. I will not expect them to be an SSD or something faster. And also cost is a driver, so yeah.
Hello, this is Daniel. I work for Nielsen, but I happen to have a question regarding the test in terms of deleting part of it and then keeping part of it when running the test. What's the criteria that you use for determining what to delete and what to keep in running a test?
In our case, we were deleting everything. Then we've just let developers set up their own fixtures, like here. So, yeah, here, like every time you run a test, it's fully empty. There is no conflicts. You just need to set up this simple fixture. Here, you will see it just points out to other dependencies. That's how we managed to do it. Instead of trying to keep global rows, which we realized could almost never happen because everyone just changes a single parameter in an empty and just reinserts. That's how we dealt with it. We just asked developers to rewrite this. Yeah.
Thanks. Any other? What?
I was interested in the screenshot you showed of GitHub, like the bot posting on there, how it was posting like I guess the performance of that particular test run. Was there a motivation, like, did people enjoy like seeing like, oh, this was like faster or slower than previous runs? Or it's a cool feature. So I'm just wondering if there was a discussion that led to you doing that.
Sorry, I couldn't quite catch. Are you asking if I was happy after running it 2 years later?
No, I guess I'm just wondering about like maybe this is built. I'm not familiar with GitHub Actions, so maybe this is built into that. But like the posting there of like how long the tests took to run, like an hour 25, I guess there. Is that like did you guys like do that custom? Like, did you get it to post like how long the test took, or is that something that's just built into GitHub Actions?
That's a custom action that should be like Enrico me GitHub Action Reporter, and we run the test in our main. It just compares it to the main branch. In this branch, I just reverted all the performance optimizations. That's how we got that 15 plus minutes.
Okay.
It's a very small question. Do you remember parameters of this machine, CPUs and memory that allows to run 1 hour half?
The original, this one is an AWS C6, maybe 2x large, 32 gigs of memory. We were using the GitHub's Excel Actions runners, and they weren't enough. Like we switched to AWS's probably C6 to Excel, 32 gigs of memory. And we've benchmarked some models like memory intensive, CPU intensive. We wanted to have that slight CPU bump to speed things up. I think that must be the one we are still using.
And your Postgres is running in a different AWS complex?
It's run on Docker. We are using test containers to run our Postgres on the side with the tests. Oh, actually, in this case, we were manually spinning up as a Docker container in the same machine. It's not in somewhere different. So we don't have the overhead of network more than that.
Okay. Any more questions? All right. So we have time. We can continue. But yeah, thank you so much again.